Hi bachcho, today we are dealing with the topic real numbers, which is the first chapter of CBSE-Grade 10, which follows the NCERT textbook. Now let us discuss in detail the concepts of chapter 1, which is regarding the real numbers. First, we have a theorem 1.1, which is nothing but the fundamental theorem of arithmetic. In this, it clearly states that we have every composite number that can be expressed or factorized as a product of primes, and the prime factorization is unique apart from the order in which the prime factors occur. This clearly shows that suppose we have a composite number, any composite number can be expressed as a product of prime numbers. For example, we have 120, which is a composite number. Now I can express this number as a product of prime numbers, which is nothing but 2 into 2 into 2 into 3 into 5. Are we interested in the order? So we can even write this as 2 into 3 into 2 into 5 into 2, which can be further expressed in terms of its powers. So we express this as 2 raised to the power 3 multiplied by 3 raised to the power 1 multiplied by 5 raised to the power 1. But the standard format that we follow is the ascending order of the prime number. This fundamental theorem of arithmetic was clearly explained by Carl Friedrich Gauss, who is also known as the Prince of Mathematicians. We have many applications relevant to the fundamental theorem of arithmetic. Firstly, we could easily find the highest common factor, and we can also find the least common multiple. The highest common factor, which is shortly termed as HCF, is nothing but the product of the smallest power of each common factor in the numbers. If we have to find the HCF of the numbers 12 and 45, firstly, we should express them as the product of the prime factors. For example, 12 can be written as 2 into 2 into 3, which is also equal to 2 raised to the power 2 times 3 raised to the power 1. And next we have the number 45. The 45 can be expressed as the product of prime factors, which is 3 into 3 into 5. So 3 into 3 into 5 can be further be expressed as 3 square into 5 to the power of 1. Now what is the common factor among both the prime factors? It is 3. But are we interested in the degree? Look at the degree. For example, for the number 12, we have the 3 raised to the power 1, whereas for the number 45, 3 raised to the power 2. So we have to go for the least one, which is nothing but the HCF of 12 and 45 is 3 raised to the power 1, which is equal to 3. Now let's see how we can calculate the least common multiple. The least common multiple is shortly termed as LCM, which is nothing but the product of the greatest power of each prime factor in the numbers. Example, let's find the LCM of the same numbers, which is 12 and 45. We know how to express 12 as a product of prime factors, and after writing the product of prime factors, we have to further write those factors in terms of powers. So what we observed is, for 12, it is 2 raised to 2 into 3 raised to 1. For 45, it is 3 raised to 2 into 5 raised to 1. In this, to find the LCM of the numbers 12 and 45, we have to look for the highest factor of all the numbers. For example, 2 raised to 2, 3 raised to 2, and 5 raised to 1. Further, we can formulate the HCF of A comma B multiplied by the LCM of A comma B is nothing but which is equal to the product of the two numbers A and B, which is A times B, where A and B are the positive integers. Will this hold good for the three numbers if it is A, B and C? Let's observe that. The HCF of A comma B comma C times the LCM of a comma b comma c is not equal to a times b times c. Though a, b, c are positive integers, this holds good with another formula which helps you in finding the LCM if you have the HCF, and similarly it helps you in finding the HCF if you have the LCM of the three numbers. The formulas are as follows. LCM of a comma b comma c is equal to a times b times c times the HCF of a comma b comma c, which is further divided by the HCF of a comma b times the HCF of b comma c times the HCF of c comma a. Similarly, it helps us in finding the HCF of a comma b comma c, which is equal to a times b times c times the LCM of a comma b comma c divided by the LCM of a comma b times the LCM of b comma c times the LCM of c comma a, where a, b and c are three different prime numbers. The next topic is real numbers. As I told you, these real numbers are real in nature, which is nothing but it is equal to the sum of all the rational numbers represented by letter Q summed up with all the irrational numbers represented by letter S. Now let's deal with the next theorem, which is theorem 1.2. Let P be a prime number. If P divides A square, then it clearly holds that P divides A as well, whereas A is a positive integer. Lastly, we have a theorem 1.3. To prove root P is irrational, P is equal to prime number. With the help of this theorem, we can prove that any prime number which is under root is an irrational number. Holding this, we know that so far everything is clear that what is a rational number and what is an irrational number. Suppose we try to add up a rational number with an irrational number, the result, the sum, is nothing but irrational. Similarly, if we are trying to subtract a rational number minus an irrational number, then the difference of the two numbers is also irrational. This completes our chapter. Hope you understand.